In this example, we are going to determine the future value for continuous compounding interest. In the previous example, we saw as the number of pay periods increases, the rate of return on our money tends to level off. We stated that this process or this value is called E. Now, E is an irrational number. That means it cannot be expressed as one number over another number like a fraction. Its value is determined as 1 plus 1 over n to the n power. And as you look at this equation, it looks very much like that of that's found in the future value. So what this says is that as n increases indefinitely, it gets higher and higher and larger, often to infinity. E approximates to 2.71828183. This is to 8 decimal places. It actually goes on forever, but it's 8 decimal places, and you can see that it's written right here. So when we use it in finance, this means that the compounding is continuous. That means that there are no gaps between the pay periods. So for example, if we have 4 pay periods throughout a year, there is a discrete amount of time between pay periods. Well, there's no such thing for continuous compounding. So what happens is this introduces us to a new formula for future value when the compounding has no gaps. This is known as continuous compounding interest. And that equation is the future value. It's going to be equal to the principal. But then we multiply that to E. And E is 2.71828183, approximates to that. And then we raise E to the R, that's the rate, times T to the time in years. So for this problem, it says determine the future value on $80,000 earning 4.5% annual interest for 5 years compounded continuously. And it says use E is approximately equal to 2.71828183. So it's good practice to go ahead and list whatever variables we know. So we have we're going to determine the future value. So we have a principal here of $80,000. We have an annual interest rate of 4.5%. The length of the loan, T is equal to 5 years. And it's compounded continuously, so we could say that N is going to be E. So for our future value, that's our $80,000. Multiply that to E, so I'm just going to do this. 2.71828183, that's to 8 decimals. And then raise it to the R times T power. So I'm going to raise it to the 0.045 times 5 years. So then in our calculator, type in the 80,000 just as we see it. Right here, I'm going to type it in just as we see it. E is 2.71828183. Close off the parenthesis. Here's my caret key. Raise that to the 0.045 times 5 power. Hit enter. And that's 100,000. $185, and of course we'll round to the nearest penny, and that's 82 cents. This is the most money that you can make if you invest $80,000 earning 4.5% for 5 years. Because this is continuous, so nothing gets no rate of return gets greater than this. Now, if you look right here on the calculator, there's an E key. I use the TI-30. Your scientific calculator should have an E key. It's right here. And if I click on it, I'll have to use my second key and hit E. E is often applied to itself several times, so it automatically has a power to it. But you can see E right here. And if I raise that just to the first power and hit enter, it gives me the 2.71828183 if we round it to 8 decimals, which of course is this right here. So what I could do is I'm going to find the future value again, except rather than type in the E approximation, I'm just going to type in E. So we'll do 80,000. Then I'm going to go to second E, that's my E key. Then raise that to the 0.045 times 5. You see how that looks? And then hit enter. And of course we come up with the same thing.